My name is Danny Forster, and this is Build It Bigger. I design buildings and teach architecture, and right now I'm going to take you behind the scenes of one of the most important construction projects in American history.
New Orleans is building the biggest hurricane protection system in the world. Starting with a 2-mile-long, 150-foot-deep surge barrier, the largest and strongest ever built.
Designed to hold back one of the single largest forces of nature ever encountered.
And inside city limits, rebuilding neighborhoods with some of the most storm-resistant homes ever constructed.
This has got a kind of a Mad Max Beyond Thunderdome vibe to it.
With hurricane season just 9 months away,
We're going.
New Orleans is coming together to protect one of America's most important cities and bring people back to the Big Easy.
This is what we doing. We bringing people home.
I'm in New Orleans, the birthplace of jazz, the home of Mardi Gras, but also the site of one of the worst disasters in American history. It's been almost 5 years since Hurricane Katrina made landfall, and New Orleans is far from having recovered. Hurricane Katrina displaced more than 1 million residents, and since the event, less than half of New Orleans' population has come back.
More than 80,000 homes remain unoccupied. The people of New Orleans are still living with the constant threat of another major storm.
So this is still a city very much in crisis.
But New Orleans has a plan to ensure the city's safety for years to come and give people the confidence to come home.
The federal government, the Army Corps of Engineers, and thousands of Americans are coming together to try and save this city.
They're rebuilding New Orleans with hundreds of state-of-the-art, hurricane-resistant homes and a radical $14 billion storm protection system.
Prior to Katrina, this wall was the only line of defense that those residents had.
It was the primary line of defense for hurricane storm surge.
Tell me what's different now.
What's different now is we've taken a step back and looked at the larger New Orleans area, and we've actually moved the primary hurricane defenses from this location to areas 8 miles away.
8 miles from downtown New Orleans, they're building this. A 2-mile-long, over 150-foot-deep flood wall that is fundamentally changing how New Orleans will fight hurricanes.
It's unlike anything ever built. The largest surge barrier in the world, nicknamed the Great Wall of Louisiana, designed to hold back over 44 million gallons of water from an oncoming storm. Prior to Hurricane Katrina, stormwater flowed into New Orleans and was met by a 350-mile network of earthen embankments called levees. Located just 100 feet from people's homes, they held back the water, keeping the city dry. But when Katrina hit, the system was so overwhelmed by water, the levees broke in 50 places, flooding 80% of the city in just 5 hours' time. To avoid this disaster happening again, the surge barrier is being built miles away from downtown New Orleans, where it can stop the water before it enters the city. Instead of waiting for the storm to come to them, for the first time, they are taking the fight to the storm.
Is this a new way to think about battling hurricanes?
Nowhere in the world have we built a wall trying to keep out 25, 26 feet of water. No one's ever done it before. And this height here on a storm surge is unique. You gotta remember, the hurricanes that come to New Orleans are bigger, meaner, and there are more of them.
To hold back a 26-foot wall of water, the barrier is fortified by 628 batter piles.
When the storm surge hits the wall, what pushes back and keeps that wall upright and strong are these guys right here. They're called batter piles, and they're basically 288-foot-long steel tubes inserted into the back of the wall that support it and transfer all the loads of that storm surge into the foundation.
Since there's no bedrock to hold the pile in place, over 80% of the wall is actually below the mudline. The deeper the pile is driven, the more friction there is to hold it in place. Each pile is almost as long as a football field and placed at an acute angle for added stability.
What'll be interesting about this lift is that this pile right here is horizontal, right? But in the end, we have to get this thing at a 57-degree angle to feed it into the machine called the leads.
No one has ever attempted to drive piles this size at an angle before. To accomplish this engineering first, the Army Corps invented a massive 1,000-ton machine called the leads. Unlike traditional pile drivers that can only hammer vertically, the leads can hammer the piles at a precise 57-degree angle. And with 4 chutes, they can drive 4 piles in a row before moving on, saving almost 5 months of construction time.
So here it is, lowering it through the leads, right? The thing that's leading it right down this 57-degree angle, getting into position so we can start knocking this straight into the ground.
Even the leads isn't big enough to handle a 300-foot-long pile in one go. So they're driven in 2 sections. The first section is 158 feet long and weighs more than 13 tons.
So Mike, as I'm looking at this slowly creep down into the earth, this is just sliding into the soil below, right?
Into the mud, yeah.
I mean, there's really nothing down there, huh?
Not much. I mean, it's soft.
It's so soft that the pile sinks 38 feet in a matter of seconds under its own weight. After that, the friction from the mud becomes too great, so they have to use a hydraulic hammer.
Do I run that hammer down?
Absolutely. Time to drive the hammer. So it's your job to control how much force this thing hits it, when it hits it, and how you drive the pile down.
That's it.
So before sun sets today, we're going to start smacking this thing and send it in?
Right now, the next 2 minutes. If everybody ready, got the earplugs on, let's go.
Let's do it. I got earplugs. I'm on. Let's start smacking it. It's on auto. So every time that smacks the pile, that pile gets pushed a little deeper into the ground.
During the first 158 feet of driving, each blow moves the pile 10 inches. But as the pile goes deeper and friction increases, it takes 40 blows to move the pile that same distance.
So Mike, the first piece is now in place.
Right.
And now they're going to bring over the second piece, which is that one right there.
Right.
Loading like a rocket launcher almost. They have to get the piece in, tamp it down, and then line one end up with the next. Line it up, line it up! All right, so here it is, coming down. And you can see we're basically gonna fit this piece into that piece, have a little bit of an overlap, and that's what they're gonna weld together. So if you look right there, you can see the weld's been completed. Those 2 separate pieces have now been spliced into one, and now that pile is 245 feet long. The weld looks good.
Yes, sir. We're ready to drive it, put it on the ground. This is the last time we're gonna see this pile in the air.
So let's flip the hammer on and start smacking.
Smacking it.
Are you ready?
Yes, I'm ready. Whenever you're ready.
I'm ready. I was born
right.
ready. I was born to smack pile.
All right.
It takes around 1,200 blows to get one batter pile into place. And to stay on schedule, they need to install 628 of them in just 6 months. A total of about 750,000 blows. Normally, a project of this magnitude would take more than 17 years to complete. To make New Orleans safe as quickly as possible, the Army Corps is attempting to finish the surge barrier in just 3. To pull off this incredible feat, this crew has to work through hurricane season. So engineers came up with an innovative solution to get the job done right and done fast, even in rough waters.
One of the biggest challenges when you're working in the middle of a lake is having a level surface on which to work, because barges move and tugboats pitch and roll as well. So in order to have a flat surface to accurately work, they developed that system right there called a trestle. It's a semi-permanent track that moves along with the wall construction.
A trestle is basically a huge railroad track anchored into the lake bed, providing a stable workplace for large machinery. The project has 1,000 feet of track for the entire 10,000-foot-long wall. So to keep construction moving forward, the trestle team has to leapfrog 50-foot sections from one end of the site to the other up to 6 times a day.
50 feet of trestle tracks about to go from this barge up in the air and extend our construction platform another 50 feet.
Each trestle segment has to be aligned seamlessly with the existing track. The gap can be no more than 9 millimeters, or about the thickness of a shoelace.
Okay, so now that we have the trestle track, generally speaking, in place between the two beams, let's walk on the trestle. I'm standing on the pre-existing trestle track, and this right here is the new piece of track. As you can see, we have a big gap. We'll use this plate right here to put it on either side of the track, put the bolts in, and bind the track together.
6 bolts need to be in place to ensure a solid connection between the trestles.
The issue is we have 5 out of the 6 bolts lined up, but one side is slightly higher than the other side, so we're having a problem getting in the final bolt.
The holes are about 3 millimeters off.
In order to make that space to get it through, we're going to torch it out. Would it not have made sense for me to move before he started? And on the plus side, actually, it's really cold and rainy. My right hand is much warmer than it was a minute ago. So, well, after cutting, torching, and hitting, and just generally some emotional consternation, the 6th and final bolt, give her a smack, is through. This track has now been extended 50 more feet. The construction site will extend. Can we go home? We're finished now?
Up next, building new lives and new hope in the 9th Ward, with houses designed to fight back against the worst Mother Nature has to offer.
These houses are being built to survive another Katrina.
When you think about what took place in New Orleans, you of course think about Hurricane Katrina. But the truth is, the actual damage that took place wasn't from the hurricane, but rather from what the hurricane created, something called a storm surge.
A storm surge is a wall of water pushed out in front of a hurricane by high winds and low pressure. During Katrina, it caused waters to rise more than 20 feet, overwhelming the existing hurricane protection and flooding almost the entire city. Katrina's storm surge was responsible for 90% of the destruction in New Orleans. And hardest hit was one of New Orleans' poorest neighborhoods, the lower 9th Ward.
I was actually here filming 5 years ago, right after the event, and it was harrowing. There were houses that were just blown clear off their foundations. Others were torn in two. I saw a house that was actually sitting in a tree.
5,000 homes were lost in this neighborhood alone, and less than 20% of its residents have come home to rebuild.
Hello?
Hi.
Miss Leggy?
Yes.
I'm Danny.
Hi, pleased to meet you,
Pleased to meet
Danny.
you. Can I come in?
Sure. I'm just about to get started some sweet potato pies.
My timing was fantastic. Tell me what you saw when you first came back.
I mean, you came here and you looked at it and you saw nothing. There was nothing here. A porch that my daddy built twice. That was it. And the tree. Everything was gone.
After all you went through, what made you want to come back to rebuild?
I didn't ever want to leave in the first place. I ain't tell nobody I wanted to go nowhere. I didn't want to leave here. I was satisfied.
This was home.
Yeah, sure. This was home.
It's been 1 year since you've been back, and a very different house,
Right.
very different neighborhood, but does it still feel like home?
Yes, getting there. It's getting there. We got cleaners now. We have different houses built up. More people are coming home. If you don't want to get this house, you can get another house. But as long as you come back is what we're looking for. Just come back.
To help people like Miss Leggett come home, actor Brad Pitt founded an organization called Make It Right. Their mission, build 150 cutting-edge homes, safer and more sustainable than ever before, starting in the most devastated neighborhood in New Orleans.
This is one of the areas that's hardest to build back because of the soils and because of the amount of displacement that occurred.
We plant the seed in the toughest soil, with some of the toughest situations in hopes of starting development all throughout New Orleans, but starting in the hardest area.
Yes.
Designed by 21 world-famous architects, these homes reflect contemporary architecture. But their unique designs are actually based on the traditional homes built in this location for more than 100 years.
New Orleans architecture is famous for having invented something called the shotgun house, and this is it. Now, the make-it-right houses, while they might look really different, are born out of the same New Orleans conditions. Key elements are super short front facade, as short as 12 feet, super long side facade, as much as 5 times as long, extra tall ceilings to keep you cool on New Orleans nights, and windows located along the side to facilitate cross ventilation. So what I'm looking at are 21 different interpretations of a traditional Ninth Ward shotgun house.
That is correct.
But they look very different.
They do, and that difference actually instills a lot of pride in the homeowners. The architecture drives the communication, and it also drives the pride. And to be able to restore pride to a neighborhood or to a community is a significant event beyond just building a conventional construction home.
It's incredible.
It's an amazing project. No matter which aspect we look at, there's something incredible going on.
These homes are re-engineering the lower Ninth Ward and transforming it into one of the most hurricane-resistant neighborhoods on the planet. But one of their biggest challenges isn't wind and rain, it's the ground itself.
Like most of New Orleans, the lower Ninth Ward is built below sea level, which basically means the ground below me is a big swamp. You build a house here, over time, it's going to sink. So to prevent that, the make-it-right houses begin construction by driving these massive 40-foot-long piles into the earth. This is what they had before Katrina, and this is what they're getting right now.
Right, exactly.
So these are real, I mean, these are built to last.
These houses are built to survive another Katrina.
These piles are revolutionizing how homes are built in this flood-prone area. Previously, homes rested on top of cinder blocks. When a flood came, the house would be lifted off the blocks and sent crashing through the neighborhood. But now, these wooden piles stabilize the soft soil so it can support a raised concrete foundation. It actually attaches to the house, strong enough to keep the home in place, even in floods more than 12 feet high.
Chris, how do you get a 40-foot pile rated to carry 7 tons into the swamp?
You use that machine over there, which is called a sonic side grip vibratory driver that puts out 50 tons of centrifugal force, and it'll push that pile underground in about 2-3 minutes.
So this is it, huh?
This is the machine.
It's like a construction action hero. My God.
Tony, why don't you spin her around so we can look at her?
This has got a kind of a Mad Max Beyond Thunderdome vibe to it, you know what I mean?
Yeah, I never get tired of watching it work.
No one has ever used a pile driver like this to install foundations in the lower Ninth Ward. Its unique articulating arm can grab, lift, and drive the pile all in one shot. The work gets done 3 times faster than if they used a conventional pile driver.
Grabs it by eye, swings it into place like it's his extended arm.
Exactly.
Puts it right down in a matter of moments.
Tony says the only place he really feels at peace is in that machine.
You can kind of see that too, right?
Yeah, oh yeah.
To lift and move a pile requires careful coordination of 6 controls all at once.
That's good.
Tony's located the pile right in the corner of the foundation. We have a little circle mark for him. And he's just gonna put this thing dead smack. Perfect. He's lined up, he's level. Now it's time to vibrate. Tony, you ready?
The pile driver exerts over 30,000 pounds of pressure.
I can feel my colon shaking.
To be sure the piles don't splinter under that force, the machine's arm vibrates 30,000 times per second. It actually liquefies the soil around the pile, reducing friction and cutting the amount of pressure in half.
You literally feel the ground shaking. Within like a 5-foot radius around Tony's workings, like my feet, my toes, my back, I'm like itchy right now from the vibrations running through me. So now what I'm standing on, even before the foundation gets here, is 40 feet of pile below me. And it's from this point the house now begins. Is it hard for a rookie?
The hardest part's picking the pile up.
Let's give it a go. I'm gonna drop some piles. Okay. So you're Tony.
Yes.
I'm Danny.
Nice to meet you, Dan.
How you doing, man?
I'm okay. We're gonna switch jobs.
Switch jobs.
Yeah.
You do the yelling and walking around and talking and not doing anything productive.
Sounds like a winner.
And I'll do the work.
Sounds like a plan.
All right, Tony. Oh!
Swing your left over.
Oh, so close. It was like I'm about to eat it. It was like, oh, here we go.
Open.
Open.
Uh-huh.
It's like playing the
There
violin.
we go.
Come here. Oh! It's in my clutches. It's coming up. I got me a good grip on it. Chris, watch this, man. This is gonna be a little piece of magic.
Can't beat that.
How's she looking?
First time out, that's not too bad.
Now tell me something. You're
that?
from here, right?
Born and raised here.
Born and raised.
Yes.
So regardless of the next event, next storm, if it happens again, you come back.
We're coming back. This is home. This is life. This is reality here. I come here sometime with my kids just to show them the houses, you know? This is what we doing. We bringing people home.
It's good
Thank
stuff,
you.
man. No, it really
Thank
is.
you.
It's amazing.
Up next, putting together the strongest wall ever built
And we're gonna literally thread the needle.
in some of the worst soil conditions in the world.
Since it was founded in 1718, New Orleans is a town that's been working against the elements, primarily because 80% of this place is located below sea level. But for the first time, New Orleanians are trying something new, working with nature instead of against it.
New Orleans is built on top of a giant marshland, which for millions of years naturally absorbed thousands of gallons of rain and floodwater. Today, most of that spongy marsh is covered by pavement, causing significant problems for this flood-prone city.
In a typical situation, when the water rains, what happens to that water? How does New Orleans deal with it?
That water runs off, goes to our curb and gutter, goes about 8 blocks to the north of us, and is pumped over a levee at about 2 cents a gallon.
Okay, that's expensive, it's time-consuming, it's a problem if the pumps fail.
It's not sustainable.
And in the past, I mean, frankly, relying on the pump station, relying on the city hasn't always worked so well for these citizens.
Over half of New Orleans is located below sea level. This paved city is basically a big bowl. When water comes in, the only way to get it out is with pumps. So when the pumps failed during Katrina, the lower Ninth Ward was left underwater for more than 3 weeks.
We're in a situation where our community has a real fear of water, and it's a valid fear of water.
Right.
So the folks in this neighborhood have a different mindset on water, and we're trying to change that paradigm.
To make sure this neighborhood is not left underwater again, engineers have found an innovative solution to radically reduce the need for pump stations, called pervious concrete.
As water runs off of our site, it does the opposite of what typical pavement does. Instead of a giant table that tilts water and flows it to the curb and gutter, this is a giant sponge that accepts rainwater, stores it in the concrete and below, and doesn't hit the curb and gutter and run off our streets.
So you're telling me this driveway and this sidewalk, when rain hits it, it's actually gonna absorb that water?
Correct.
Unlike conventional concrete that repels water into the storm sewer, pervious concrete absorbs it. Filled with tiny air pockets, it allows water to flow through it and into the native marshland below, where hundreds and thousands of gallons can be stored naturally.
Do you have any actual finished stuff that we can see?
Yeah, we have a little mock-up right here.
It actually does look like a
Rice Krispie treat.
Rice Krispie treat. Look at that. All right, let's simulate right now. I'm a driveway, you're a rainstorm, and the rain's coming in.
It just stores up,
It's
and
just eating it like a sponge.
then it comes out the bottom.
And it's coming out the bottom. Look at that. Now, typically, all that rain we just dumped down would go from this driveway into the sewer system and have to get pumped out.
Correct. At ultimate build-out, we will be saving several 100,000 gallons of water hitting the storm sewer every rain event.
And that all starts with you, me, and a bunch of guys pouring some concrete.
Absolutely.
Here comes. It doesn't look normal, right? It's much drier, thicker, and chunkier.
Because of this consistency, Pervious concrete pours much slower than conventional concrete and dries much faster. So we have just 15 minutes before the concrete sets.
So we're actually trying to push the concrete out, but then actually compact it.
Yeah, we're gonna compact it. We're gonna pour it 3/4 of an inch higher.
Got it. What I'm doing right now is sort of the opposite of what you do with normal concrete. Typically, you vibrate concrete to get the air bubbles out. Here, we actually compact it tight to get lots of air bubbles inside of it. That's how the water goes through it.
Compacting the concrete is the most critical part of the process. If it's compacted too tight, it won't absorb the excess water. Too loose, and it'll crumble. To do the job quickly, they use a specialized 150-pound roller called a screed.
Ready?
You wanna pull it?
Yeah, now I'm pulling it. All right, come to me, here we go. Stay with me, here we go, nice and slow. I'm making pervious concrete, you know why? Because I don't want concrete to push water into the sewer system, do you? No, you don't.
Good job, good job. That was perfect. Beautiful.
And although it may not look like it, this is actually the finishing touch. This is the layer of concrete that you'll see every time you walk down the Make It Right streets. Big, hard, dense Rice Krispie treat that all the while is sucking up the water and making sure it does not go into the streets. I love it, man.
The concrete will absorb 5 gallons per hour, using Louisiana's natural marshland to keep the neighborhood dry. That same absorbent soil, however, is the biggest problem for engineers building the 2-mile-long surge barrier.
So for me, what I'm fascinated by is that you want this to be strong and heavy and beefy. But if it's too heavy, the soil is so weak, your wall will actually start sinking.
That's one of our challenges. We need a very strong wall, but you also need a light wall. Comparatively speaking, for concrete, of course.
Right.
We can't build a Great Wall of China here because the massive weight of it would simply sink out of sight.
Instead of building one solid structure, like most levees or dikes, engineers designed the New Orleans surge barrier as an A-frame. It uses half the material, but it's actually stronger than a solid structure. The key to its strength? 330 concrete caps placed at the top of the A. They link the vertical piles to the batter piles, directing the force of the storm from the front of the wall, through the batter piles, and down into the marsh, dispersing the loads and keeping the wall strong but light.
All right, so Vic, when the soldier piles are in, the batter piles in place, what ties them all together and makes them one structural system are these guys right here.
That's right. These are caps.
So essentially, your chain is as strong as your weakest link.
Yeah, absolutely.
And this is the link, essentially. This is what connects the two types of piles.
Right. This 96-ton piece of concrete, very high-tech design, transfers that energy.
Before the cap can be lifted, each joint has to be reinforced with a waterproof seal installed between the cap and the piles.
This is the seal.
This is the seal, right?
It's like the gasket.
Yeah, to hold the concrete on.
Keep it tight.
Yeah.
To make sure the batter pile meets the cap and you get one tight joint.
Yeah.
The seal between the cap and the batter pile is created by the weight of the 96-ton cap.
Luis, AKA Jackson Pollock of the glue.
Luis uses construction glue to hold the seal in position while the cap is lifted up onto the wall.
All right, Luis, let's pop it on. Okay. 96 tons, holding back 200 billion gallons of water. And during construction, duct tape. How's she looking, Luis?
Looks pretty good.
Pretty good?
Yeah, looks good.
Very good?
Very good, I say.
Okay, that's it. Our full shackles are attached. This now 96-ton cap piece is about to get lifted up from this barge and placed atop the flood wall.
The 300-ton crane is located on a barge, causing the cap to bob and swing during the lift, making the precise alignment a real challenge.
And we're gonna literally thread the needle, take these 3 shear pins, which extend the soldier piles, and put them right into the cap, fusing them into one.
Once in place, the cap transforms the wall from 5 separate elements into one structural unit for the first time.
Even as it comes down a few inches, 96 tons or otherwise, a little bit of motion can still move the thing. So we're shifting over just a couple millimeters. So as you can see, the cranes are detached, sending the shackles home. This is in its final location, 96 tons lined up within millimeters. One down, move on to the next one. Up next, we're going.
Come to Papa.
Racing to fuse the wall together with one of the fastest concrete assembly lines ever designed.
You can open it on up now. Open it on up.
But first, what wind speed can the new Make It Right houses in the Lower Ninth Ward safely withstand? The answer after the break. The answer to our trivia question: the Make It Right houses can safely withstand 200 mile-per-hour winds, enough to survive a Category 5 hurricane.
Given the amount of investment that's going into saving this city, sometimes the question is asked, should we save New Orleans? But it's important to point out that this is more than just Mardi Gras. New Orleans represents 1/4 of all domestic oil production for America. The Port of New Orleans is one of the most important ports we have. It's the very gateway for all shipping traffic to the Midwest.
This port is so important, it's been defended for more than 200 years. The surge barrier is designed to continue protecting the port and the 2 million people in and around New Orleans for years to come.
We're constructing a wall here which we know is pretty robust. I mean, several hundred years from now, this structure will still be here because nobody's going to take it. It's not coming out anytime soon.
Right.
Okay? So the reality is this will provide viable surge protection for the city of New Orleans for a long time to come.
This massive wall is engineered to last for 100 years, but they have to build it in just 18 months.
And you guys have basically designed a system for speed.
Yes, for speed, big time. Engineers, they've been thinking about this for a long time. We're just making it work.
To save time, they're using an assembly line. First, a crane drops in prefabricated concrete caps, leaving a 6-foot gap between them, not wasting time lining them up. Then behind them, another crew fuses the caps together with poured concrete, smoothing out any misalignments. This system shaves off more than 6 months.
So essentially, rather than have to worry about fussing and getting it just right with millimeter tolerance on site, they just keep moving. Because even if he's a little bit off, misses the mark a little bit, Rusty comes in, just fixes it up.
That's it.
It's like Legos with a little bit of silly putty in the middle.
That's it.
Right?
Yeah, you got it.
To fill the space in between the caps, they pour the concrete into custom formwork.
And what we're looking at right here is essentially a 10,000-pound mold, right? A shape that we're going to bring into place, which is shaped exactly like the precast caps, put it in place, and bring 2 precast caps formed together as one.
Cabling on down. A little bit. All right, we got our hands on it. Hold that. A little bit of right swing. Down easy. 6 more inches. A little bit. All right, hold that. Another shot of boom up now. Booming up.
You done this before?
A few times.
The formwork snaps into place with alignment pins, matching up perfectly with the 2 caps on either side. This snug fit allows the poured concrete to smooth out any minor errors in the placement of the cap.
Okay, Rusty, so when I got here about 15 minutes ago, there was a big gap in between these 2 pieces of precast.
Big hole.
Form is now on.
Both of them.
Done incredibly quickly.
Yes.
Tighten up the bolts, put in the pins, and then pour some concrete.
The team now needs 36 tons of concrete to fill the gap. But they've got to transport it from the concrete plant 2 miles away to the construction site in the middle of Lake Bourne, all before it starts to dry.
There it is, coming around the corner right now.
There. So here's the concrete.
It takes about 15 minutes from where we're at right here to get to the dock. And then naturally it takes them about 10 minutes to load and then 15 minutes back out.
Since they're losing about a half an hour in transit, Rusty's team now has a narrow 60-minute window to pour the concrete before it cures.
We're going
right now.
Come to Papa.
To fill the gap, they have to lift 9 bucket loads in under an hour.
You can open it on up now. Open it on up. That's it. Let's go get another one.
That's it, we just keep going. Well, there it is. As fast as she came, she went 2 yards of concrete in the hole, down the chute, and in the space. 2 yards go out, 2 more yards are coming in.
2 more yards coming.
It just comes in fast.
Coming on down.
Here it comes.
Once the gap is filled, it'll dry in 2 days.
Doing good at it, man. Doing good.
Permanently fusing the caps into one monolithic concrete structure.
All right.
Whole thing took us, what, 15 minutes?
Probably 15, 20 minutes.
When you're doing a job like this, pouring this concrete, it's not hard to remember why you're doing it.
Everybody out here enjoys coming out here, because we are building it for a reason and for a cause. Like I say, to save people's lives, property, and all that.
You get a sense that this thing is done right, this wall gets done in time, this city's gonna start to come back?
Oh, yes. I believe that 100%.
Yeah?
Yes.
This innovative concrete assembly line is giving New Orleans a barrier that will act as the primary line of defense. And on a smaller scale, another revolutionary type of concrete is being used as a second line of defense to design homes 3 times stronger than normal.
The design of the Make It Right houses is to survive a hurricane, but it's also to last the test of time. So instead of wrapping them in traditional wood siding, which rots over time, they're trying something new. They're wrapping these houses in cement.
They're using something called hardy board, a cutting-edge siding made of compressed cement designed to last for over 50 years.
So what do we have in this environment that bangs up the siding so badly?
A lot of rain, humidity, storms. You're in the Gulf South, a lot of moisture.
So the outside of these houses are kind of getting slaughtered.
Absolutely.
And so what's different about this cement board?
It will not rot away.
This siding is made of an innovative compound that does not mold or rot when wet. Unlike traditional houses that have to be demolished after a flood, this house will simply dry out in the sun. But in order to do its job, the siding has to stay on the house, even in Category 5 winds.
Because I guess during a hurricane event or any strong storm event, there's that suction where they actually pull the skin off the building.
If that corner was to come off during a high wind, it would take that sheet, and probably that sheet, and keep on going.
They've calculated the position of every nail to ensure the siding is windproof.
There is something tank-like about taking a house, wrapping it in a kind of thin cement frame, and then keeping your nail patterns hard like rivets.
Absolutely, like armor plating. This house is going to be here for a long time.
So how do we install the cement fiberboard?
We got some guys up top getting ready to install some right now.
It's only a ½ inch thick, but this 4x8 piece weighs almost 80 pounds, twice the amount of traditional wood siding.
There it goes, cement board to the sky. So I'm now standing at the 3rd floor of the house, and what you're looking into is actually an outdoor covered deck, and it's on this underside of this covered area we're gonna apply this board. All right, fellas, how you doing?
Watch your feet.
So you're from Louisiana?
New Orleans.
An amazing place, nice weather, sick architecture. Oh, and heavy cement board.
Yeah, we're just gonna kind of roll it over.
It takes 6 people to position this single panel.
All the way over?
It has to be perfectly flush with the previous board in order to form a windproof seal.
No, a little higher. Come on up. There we are. Who's got a nail gun?
Right behind you.
Far side over here. Up top?
Yep.
That is on pretty damn tight, isn't it? Nope. And that's it. Look at that. That quickly, about 8 feet of siding, the very outside of the house, what will keep rain out of this thing, keep it dry, and lasting 50 years. Isn't that right, Troy?
50 years.
50 years.
Once they put paint on there, and she'll last a while.
Coming up, finishing the world's largest surge barrier with a medieval castle-like design that can slice through 100-foot waves.
You look at it, you think it just looks cool, like you got archers shooting bows and arrows.
But there's a reason behind it.
There's a reason.
New Orleans' new 2-mile-long surge barrier will give residents much-needed hurricane security. But it's difficult to rebuild with confidence until it's done. With the next hurricane season just 9 months away, this construction team is working around the clock to finish in time.
Well, it's about 8 p.m. The sun is set, the moon is out, and I'm going to work right now. You see, given this non-negotiable deadline of finishing this wall before hurricane season 2011, the guys are not just working 7 days a week, but also 20 hours a day. Rick, Max.
Yeah.
Father, son. Formwork crew.
Yes.
What is it, the graveyard shift?
Just about, yes, sir.
It falls to the night crew to finish one of the surge barrier's most crucial elements, the parapet wall.
You look at it, you think it just looks cool, like it's like a castle thing. You got archers shooting bows and arrows.
But there's a reasoning behind it.
There's a reason. It's actually part of the system that beats down waves.
That's it.
While the lower part of the wall holds back the storm surge, it's the upper part of the wall that takes on the massive waves on top of the surge. Its castle-like notches are designed to chop big waves into smaller, less destructive ones that splash harmlessly on the backside of the wall, preventing millions of gallons of water from ever reaching the city.
In terms of what's actually fighting the storm and fighting the waves,
this is what does it right
This
here.
is it, right? This is the final edge of this thing that's actually going to hold back the water.
That's it.
And we're pulling off that form tonight.
You're going to see what it looks like when we pull it off for the first time.
The parapet wall is made up of 2-foot-thick concrete poured each morning. To keep the daytime crew on schedule, the night shift has to remove and reset 2 of the massive 36-foot molds in just 6 hours.
So by day, they place the concrete. At night, we pull the forms. We set the forms. Next day, they come back. They pour the concrete. On and on.
That's it.
It's
ongoing.
Ongoing.
Got a mile and a half of it to do. We got to get busy, stay busy.
Should we do it?
Let's do it.
Let's get
I'll be up on top.
On top? Let's go. All right.
The forms are 8 feet tall and weigh over 10 tons. To lift them, the crew needs the biggest crane on site, the mammoth 240-ton barge crane.
Rick's putting a little bit of tension in the line to look at the shackle, make sure it looks right, they're even, they're not pulling, they're not buckling. If he's happy, we're going to get off it, start to lift. What do you think, Rick?
It's holding good. Let's go ahead and get down.
All right. The formwork is ready to go. Crane has tension. And as it comes up, what you'll get to see is the exposed parapet for the first time. So just as we gotten this thing off, we revealed the finished concrete wall, cleaned it, not a moment too soon. We're going to pop it back onto the rebar and begin the process all over again.
It all starts over again.
There's no time to waste here, is there?
You're holding up the show. Let's go.
The most important step is to knock out the wooden blocks that form the parapet wall's wave-chopping notches.
A couple of smacks, pop it up, take the pry bar, pry it off.
Yeah.
All the while do it such that we don't damage it so we can reuse it on the next form.
You got it.
I'm on it. Who needs a pry bar?
This way it's supposed to come off and stay intact.
Look at that nice edge. So we'll pop a couple more of these off? Or they'll pop?
Pop a couple more and we'll go check on the form, see if it's ready to go.
I promise I won't break them.
Take care of it.
Nice, smooth, 90-degree, notched out finish.
With all 12 blocks removed, the wall is 36 feet closer to completion. Only a mile and a half to go.
Do you get that sense that after 5 years, New Orleans is beginning to get back on its feet?
It's starting to get back. They ain't never gonna take it away from Louisiana. We're still got it. We're just putting it back together so we can enjoy it again.
And this wall's a big piece of that.
It's gonna be a big part of it. Makes you kind of proud of what we're doing. Right now we got work to do. We need to get this done.
Understood.
In just 11 months, the surge barrier will be operational, giving the people of New Orleans hurricane protection that they've never had, and the confidence to come home and rebuild in the city that they love.
See, this is my home away from home. And I just love looking at New Orleans.
So, Miss Leggett, when someone who's not from here, they look out and they say, has New Orleans got a shot? Is it going to come back?
I tell them yes.
Yeah?
Yes. Good shot. Good shot.
Miss Leggett and more than 300,000 others have already returned to New Orleans to rebuild and transform their city. The recovery of New Orleans is a complicated issue. On the one hand, if you don't hold back the water, the city just won't survive. But beyond fortifying walls, it's also about building a community, a place people want to call home. It's part infrastructure, but it's also part dining room table. And what I found in New Orleans is that they're actually doing both. 8 miles from here, the new surge barrier will hold back the next Katrina. Here in the lower 9th Ward, one of the worst hit areas, you're seeing more than just signs of recovery, you're seeing a full-blown redevelopment. The Make It Right houses are taking what they learned from the tragedy and transforming it into innovation. And that, in the end, is what real recovery is. Taking the existing culture of New Orleans and transforming it into something new.